In this video, we're going to look at some more symmetry. This time we'll be testing an equation for symmetry about the axes and the origin. Okay, so recall that your x-axis symmetry comes when you replace y with negative y and you get the same thing back. Okay, y-axis symmetry is when we replace x with negative x and you get the same thing back. And then origin symmetry, if you replace x comma y with negative x comma negative y, okay, so we're replacing both, and if it comes out to be the same thing, then you have origin symmetry. Okay, so let's look at this. We have this first equation that says x is equal to y squared minus 7. Okay, so does it have x-axis, y-axis, or origin symmetry? Well, first let's test for x-axis. We're going to replace y with negative y. So we get x is equal to negative y squared minus 7. Now what happens when we square this negative y? Well, when you square something negative, a negative times a negative becomes a positive. So this becomes x is equal to y squared minus 7. The negative goes away because it gets squared out. So we get the same thing back that we started with. When we replaced y with a negative y, we came back with the same thing. So this means it does have x-axis symmetry. Okay, let's look at y-axis symmetry. So we're going to replace the x with a negative x. So we get negative x equals y squared minus 7. Okay, so is that the same? Well, we could try to manipulate some negatives around, but nothing's going to make this negative go away by getting squared or anything like that. So this is going to be a completely different equation. We could solve it for x even, but if you divided both sides by a negative 1, then the right side will be different. It would be negative y squared plus 7, which is not the same as what we started with. Okay, so this is a no. We did not get the same thing back that we started with. Okay, so we look at origin symmetry, and first of all, if you get a yes and a no, then it's automatically going to be no origin symmetry. For origin symmetry to exist, you have to get either 2 yeses on these two kinds of symmetry or 2 no's on this kind of symmetry. Okay, so since we got a yes and a no, we already know that origin symmetry is not going to work. Okay, so let's confirm it by replacing y with negative y and x with negative x. So that gives me negative x is equal to negative y squared minus 7. Okay, so I have to keep that negative in here. So this gets squared out and becomes positive, so negative x is equal to negative y squared, positive y squared, excuse me, minus 7. So just like here, it's not the same, right? We could make this x positive, but then these signs would change and be different than the original. So as we thought, this does not have origin symmetry. And if you get a yes and a no, then it's always going to be a no on origin. Okay, let's look at another one. Y is equal to negative 7x minus 7, so it looks like a linear function here. Y is equal to mx plus b. So let's test for x-axis symmetry. I'm going to plug in y, negative y in place of y, so I get negative y is equal to negative 7x minus 7. Now if I try to get this back in terms of y, I would have to divide everything by negative 1, and that would give me y is equal to 7x plus 7. Is that the original? No. These 2 signs changed, right? So this is no x-axis symmetry. Okay, let's test y-axis symmetry. So I'll plug in a negative x. So y is equal to negative 7 times negative x minus 7. So that's y is equal to, that would be 7x minus 7. Is that the same as the original? No, it's not. Okay, so this is a no. Okay, but you still have a chance for origin symmetry. If you get no and no, there's still a possibility you can get origin symmetry. If you get yes and yes, you will have origin symmetry. But just because you got both no's does not mean we don't have origin symmetry. We have to make sure. So I'll plug in a negative y for y and a negative x for x. So I get negative y equals negative 7 times negative x minus 7. So that's y, or negative y, is equal to 7 x minus 7. If I divide negative 1 on both sides to make that y positive, I get y is equal to negative 7x plus 7, because negative divided by negative is a positive. So this is very close to being a yes, but this is a plus 7 here. And the original equation did not have a plus 7, it had a minus 7. So on this particular one, we get all three no's. And quickly, I can show you what the graph looks like on that one. Okay, so let's put this up here. It's crossing at negative 7, 2, 3, 4, 5, 6, 7, and it has a slope of negative 7 over 1. So we'll go backwards. So it would start here, and it would go here, and then way up. So it looks like if you had all of the graph here like this line would look something like this on the axis, which of course doesn't have any kind of symmetry at all. It's just going down here, crossing the x and y axis at some random point down there. So that one for sure has no symmetry. Okay, let's do three more here. Okay, for the first one, for x-axis symmetry, I'm going to replace y with negative y. So I get negative y equals 2x cubed. Okay, divide by negative 1 so I can get that y to be positive again, and that gives me negative 2x cubed. So this is different. So this is a no. Okay, y-axis symmetry, so let's replace x with negative x, so y is equal to 2 times negative x cubed. Now, when we cube a negative, it stays negative, because it's going to be a negative times a negative times a negative. Two of those will multiply to get a positive, but then there's one remaining. So this is going to be equal to negative 2x cubed, and that's not what the first one was, so this is a no for sure. So again, we get no, no. But again, that doesn't mean that we don't have origin symmetry. We have to try. So let's replace both now. So here's a negative y equals 2 times negative x cubed. Okay, so you get negative y is equal to, we already know this stays negative, so negative 2x cubed. And if I divide by negative 1, I get y is equal to 2x cubed. That is the same. So even though we got no and no on x-axis and y-axis symmetry, we do get a yes on origin symmetry. And here's what that graph would look like if we graphed it in the calculator. You can see that the corners look the same. These two are empty, and these two are the same. So think about this one right here first getting reflected down. So it would look like this, and then getting reflected across, and it would look like this. Okay, so it does clearly have origin symmetry. All right, let's take a look at the next. So y-axis symmetry, or x-axis symmetry, I'll replace the y. So I get x is equal to negative y to the fourth minus negative y, that is a minus negative y squared, minus 10. Okay, so we raise that to the 4 power, and that's negative times a negative times a negative times a negative, which is going to be a positive. So that will be positive y to the fourth. You get squared on this one, so the negative on the inside goes away because it's getting squared, but there is a negative still on the outside. And then minus 10. Okay, so do we get the same thing? Yes, we do. So this does have x-axis symmetry. Okay, y-axis symmetry, I'll replace the x with negative x equals y to the 4 minus y squared minus 10. You may already see this is not going to have the symmetry, because in order to make this term positive, I'll have to change all these signs. So x is equal to negative y to the fourth plus y to the 2 plus 10, which is not what the original one was. So this is a no. And since we got a yes and a no here, we're definitely going to get a no on origin symmetry. Okay, because the answers were different. But we can show real quick, so let's replace both. There's my negative x equals negative y to the fourth minus negative y squared minus 10. So that's negative x is equal to y to the fourth minus y to the 2 minus 10. If I change all the signs just like I did before, over here, I'll get x is equal to negative y to the fourth plus y squared plus 10, which is not what the original one was. So as we knew already, that was a no. So anytime you get two different answers for x-axis and y-axis symmetry, you automatically are a no for origin symmetry. All right, last one. X-axis symmetry, let's replace y with negative y. So you can already see without even writing down, if I put a negative y in here and it gets squared, it becomes positive. Nothing else will change, right? So it does have x-axis symmetry. Let me go ahead and write it down real quick though. Plus x plus 9 equals 0. This negative gets squared and becomes y squared plus x plus 9 equals 0, which is the same as the original one, so that is yes on that. Okay, x-axis or y-axis symmetry. So y squared plus negative x plus 9 equals 0. So y squared minus x plus 9 equals 0. That is not like the original one. The x is the wrong sign. So that's a no, and we know that this is going to be a no as well because the answers were different there.